Have you ever wondered how the weather in space might impact our lives on Earth? This might seem like an abstract question, but it's one that has very real implications. When we talk about space weather, we're referring to the changing environmental conditions in near-Earth space. These changes, often driven by activity on the sun, can have far-reaching effects. Just like we have weather patterns here on Earth, space has its own weather systems too. But instead of rain, wind or snow, space weather involves solar flares, streams of high-speed particles and magnetic fields. It's a cosmic ballet, a dance of energy and matter that unfolds across the vast expanse of our solar system. Why is understanding space weather so important? Well, for starters, space weather can disrupt satellite communications. In our interconnected world where we rely on satellites for everything from GPS navigation to television broadcasts, even minor disruptions can have significant impacts. Imagine being in the middle of an important call, and suddenly, you lose signal. Or picture yourself navigating through a new city, and your GPS goes haywire. That's the kind of scenario we could face if a powerful solar storm hits Earth. Furthermore, space weather can also affect power grids. A strong geomagnetic storm can induce currents in our power lines, potentially causing blackouts on a massive scale. Picture a city plunged into darkness, all because of a storm happening millions of miles away. Lastly, understanding space weather is key to planning future space missions. Astronauts venturing into space need to be aware of space weather conditions to ensure their safety. A sudden solar flare, for instance, could expose them to harmful radiation. In other words, space weather is not just a matter of scientific curiosity. It has real, tangible implications for our day-to-day lives, our technology, and our future explorations of the cosmos. And that's where the Aditya-L1 mission comes into the picture. It's this mission that's paving the way for us to gather crucial data on space weather, helping us understand and prepare for its impacts. So stay tuned as we delve into the fascinating journey of Aditya-L1 in the next scene. On a clear morning, the Indian Space Research Organization launched the Aditya-L1 mission. A day etched in the annals of space exploration as a new chapter unfolded in our understanding of the cosmos. The Aditya-L1, fondly referred to as India's sun chaser, was not just any routine satellite. Its mission? To venture where no spacecraft from India had gone before, towards the sun. As the countdown hit zero, the roar of the launch vehicle's engines echoed through the air, a testament to humanity's relentless pursuit of knowledge. The mission had a clear-cut objective: to study the sun's corona, the outermost part of the sun's atmosphere, visible only during a total solar eclipse. The corona, although less bright than the sun's surface, is incredibly hot, with temperatures soaring over 1,000,000 degrees Celsius. The puzzle of the corona's mysterious heat has intrigued scientists for decades, and the Aditya-L1 was set to unravel this cosmic enigma. But why study the sun's corona? Well, it's the birthplace of solar winds, streams of charged particles that speed away from the sun at 1,000,000 miles an hour. These solar winds affect the space environment around Earth, leading to what we call space weather. From interference with satellite operations to disruptions in power grids on Earth, space weather has far-reaching implications. The Aditya-L1 was designed to give us a closer look at these phenomena. With a suite of 7 scientific instruments, the satellite was equipped to capture high-resolution images of the sun's corona, measure the electromagnetic fields around our star, and monitor the solar wind particles. The data gathered would not only enhance our understanding of the sun, but also enable us to predict and prepare for space weather events. The launch was a spectacle to behold, a symbol of human ingenuity and perseverance. As the Aditya-L1 streaked across the sky, it carried with it the hopes and dreams of a nation, and indeed of the entire scientific community. A mission that was more than just a scientific endeavor. It was a journey towards a deeper understanding of our place in the cosmos. With a successful launch, the 127-day journey of the Aditya-L1 had begun. A journey that promised to shed new light on the secrets of our sun and the mysteries of space weather. Aditya-L1 embarked on a journey that would not only test its capabilities, but also provide invaluable data on space weather. Setting off from its earthly confines, the spacecraft found itself on a path of discovery, spanning a distance of approximately 1.5 million kilometers from our home planet. A journey into the unknown, where the only constant was the silent hum of the spacecraft's instruments against the backdrop of the infinite cosmos. The journey of Aditya-L1 was not just about reaching its destination, but about the lessons learned and the data gathered along the way. With each passing day, the spacecraft faced a slew of challenges that tested its resilience and the team's problem-solving skills. One of the key challenges was the sheer distance that the spacecraft had to traverse. With the increasing distance, the communication delay became a significant factor. To overcome this, a high-frequency communication system was deployed, ensuring the constant flow of data between the spacecraft and the ground station. Another challenge was the intense radiation from the sun. In order to protect the sensitive instruments on board, a robust thermal protection system was put in place. This not only shielded the instruments from the harsh solar radiation, but also kept them at optimal operating temperatures. During the journey, Aditya-L1 conducted numerous scientific experiments. These experiments were designed to study various aspects of solar physics and space weather. From capturing high-resolution images of the sun to measuring the solar wind, Aditya-L1 left no stone unturned in its quest for knowledge. One of the key experiments was the study of coronal mass ejections, or CMEs. These are massive eruptions of plasma and magnetic fields from the sun's corona into space. Understanding these eruptions is crucial in predicting space weather, which can have significant impacts on satellite operations and communications on Earth. Despite the challenges, the journey was filled with moments of triumph. Each hurdle overcome, each successful experiment conducted, brought the team closer to their goal. Every bit of data collected added to the growing body of knowledge about our sun and the space weather it influences. But the journey was not just about the destination or the data. It was about the spirit of exploration, the thirst for knowledge, and the relentless pursuit of understanding the world beyond our own. It was about the collective effort of a team, their dedication and their resolve to push the boundaries of what is known and venture into the unknown. After a journey of 127 days, the Aditya-L1 arrived at its destination. But this was not the end. Rather, it marked the beginning of a new chapter in the story of space exploration and our understanding of the sun and its impact on space weather. After a journey of 127 days, the Aditya-L1 arrived at its destination. The data gathered by Aditya-L1 provided unprecedented insights into the space weather. Aditya-L1, in its 127-day journey, accumulated an extraordinary amount of data that will shape our understanding of space weather for years to come. This data, the findings, are like a treasure chest of knowledge, waiting to be unlocked, revealing the secrets of our sun and its influence on our planet. One of the key findings is the continuous monitoring of the sun's outermost atmospheric layer, the corona, which has never been done before. This is significant because the corona is the source of solar winds and coronal mass ejections, phenomena that directly influence space weather. Data from Aditya-L1 also provided a more comprehensive understanding of the sun's magnetic field. This is crucial because the sun's magnetic field plays a significant role in shaping the solar wind and triggering space weather events. Moreover, the mission discovered previously unknown aspects of the sun's photosphere, the layer we see with our naked eye. This data, coupled with the information about the corona, will help scientists develop more accurate models of the sun's atmosphere. But what does all this mean for us on Earth? Well, understanding space weather is vital for our technologically driven society. Solar storms can impact satellite operations, disrupt communication systems, and even cause power grid failures. By understanding the sun's behavior, we can better predict and mitigate the effects of these storms, safeguarding our technologies. In addition, this data can help us understand the broader cosmic weather. This could potentially aid in the exploration of other planets and even galaxies, by helping us predict and navigate through the challenges posed by the extraterrestrial environment. The Aditya-L1 mission has truly been a game-changer, a giant leap in our understanding of space weather. It has opened up new avenues for research and exploration, and its findings will continue to be analyzed and built upon for years to come. The Aditya-L1 mission not only achieved its objectives but also paved the way for future space weather studies. The Aditya-L1 mission marked a significant milestone in space exploration. This mission wasn't just a journey of 127 days, it was a journey of innovation, determination, and remarkable scientific achievement. The legacy of Aditya-L1 goes beyond its successful orbit around the sun. It has opened a new chapter in space weather studies, providing crucial data that has enhanced our understanding of solar storms and their impact on Earth. Thanks to Aditya-L1, we can now predict space weather with greater accuracy, a leap forward for space science and technology. Yet the influence of Aditya-L1 doesn't stop at space weather. It has set a precedent for future space missions, showing us that we can reach further, aim higher, and dream bigger. It has inspired a new generation of scientists, engineers, and astronauts, reminding us that the sky is not the limit, but the beginning. The journey of Aditya-L1 is a testament to human ingenuity and the endless possibilities of space exploration. As we witness Aditya-L1's remarkable journey into the heart of our cosmic neighborhood, let us anticipate the wealth of knowledge it brings. Subscribe to stay connected with the latest updates on space exploration, and remember, the cosmos continues to inspire us with its infinite wonders. Until our next celestial exploration, keep looking up.